welcome back. This is the final seminar for the term. And it's a completely new one. I've never given anything like this before. So this is charades. And mathematicians do. Because we spent 7 seminars now talking about ethical issues in math and where things go wrong, and it gets kind of easy. Just sort of sit there and go, that was wrong. That was wrong. I mean, you mark an example sheet, it's great. It's like wrong. What's the answer? That was wrong. So here's actually the tough bit. Giving you ideas and suggestions as to what you might do in the future. Not just telling you what not to do, but what you might actually want to actively try and do. This is a harder question. So this goes way beyond what we've ever sort of discussed in ethics and math in the past. And part of the motivation for this was, back in the old days, in 2006, when we first started doing this, some students, after a few seminars, they said, okay, fine, we get it, there's ethics in math, shut up, stop telling us, we understand. What are the axioms of an ethical decision? I can't give you axioms. Okay, wait. Well, can you give us an algorithm to solve ethical problems? No, you're not listening. So students were asking for sort of the algorithm to solve ethical problems and the axioms for ethics, and I said, no, there's ethical scenarios are a thing you have to solve at a very human level. Understanding exactly what's going on in their surroundings. I can't list it all for you. But then some students asked a more sensible question, which was, okay, get your point, there's ethics in math. What do I do if I want to act on this? What do I do if I want to be ethical? And I hadn't thought about this at the time, because I'd spent so long trying to tell everyone to stop blowing things up, that I hadn't actually thought forward and said, well, if you want to actively be, ethical and do good, what can you do? Hadn't really registered to me. I mean, I'm sure there's some things, but I hadn't quite thought about it. But that was over 2 years ago, and since then we've had time to think about it. And now we have what is sort of a framework of what you might do. And Pearson, Dennis and I have spoken about this far longer than we probably ever should have. And we call this
No, I'm leaving.
I want to leave, that's the best. All levels of ethical engagement. A mathematician. SPS actually left the room. Yes. Well, actually, 4 levels and the non-level. So this is an observation of the sorts of ways that mathematicians act on their ethical awareness. So we've, after 2.5 years of thinking about this and watching mathematicians do stupid stuff and not so stupid stuff and actually pretty sensible stuff, we thought, okay, how do we sort of write this down and characterize it? So, I'll go sort of straight into it. Level 0. I think that summarizes it perfectly. There exists no ethics in math. I love you can package up an idea so succinctly in mathematical notation. So level 0, which is probably where like 99 point whatever percent of mathematicians currently reside, is the simple belief that there is no ethics in math. I just do scribbles on paper, it's all on the abstract, can't blame me, no problem. And people at this level, so most mathematicians, fail to see that the mathematician is the human link between the abstract truth of mathematics and the effects of its use. Somebody at some point has to pick up math out of the abstract and plug it into what's actually going on in the world. And that somebody is us. So level 0 is pretty easy. Everything's in math. It's also where most of us reside. So I sort of like to phrase this as no one needs to think about what we're doing or what they're doing. Okay, that's level 0. Level 1 seems to be the most meaty of these levels of ethical engagement. Level 1, essentially, there exists ethical issues in mathematics. And I sort of used to think that, okay, there are two types of mathematicians. There are the ones who think there's no ethics in math, and the ones who think there's ethics in math. But actually, you can go beyond this. We'll talk about this a bit later. So level 1 is exactly what, so this is this seminar, this lecture series. Thank you, faculty board, for the promotion. This lecture series. So this entire lecture series has all been about explaining level 1. So, understanding that we as mathematicians, we exist in a social and political matrix, and that the stuff that we do carries ethical consequences, because we're doing stuff. Anybody doing stuff has to think about what that stuff is going to lead to. So we make and wield tools, and these can be used for good and for harm. And these are the sorts of ideas that we've been discussing. So what might you actually do if you've reached this level? Well, it can be sort of fairly simple stuff. You might be working on a project and decide that, well, rather than building a highway straight through a rainforest, because it's the cheapest and fastest way to do it, you might think, well, let's actually sort of ask a few more questions and produce a solution that makes a bit more sense, not just for maximizing profits of said company, but for society as a whole. So sort of moving off the A4 page that we're so comfortable living on, and going, okay, we'll ask some more questions about what we're doing, about why we're doing it. You know, maybe you're in Facebook and you sort of pause for a minute and say, hey guys, because it's kind of all guys working there, guys, maybe we shouldn't be collecting these terabytes of data on every single person in the world. Maybe we should like delete some of it, or like not make it so easily accessible to these app developers who we have no idea who they are. So these sorts of discussions. So essentially, you know, actions can be as simple as, you know, stop doing stupid shit, which is great. And if everyone piles onto level 1, my job is kind of done. I'm happy, I can retire. There we go. But I can't, because there's sort of people, plenty of people here. But actually, if you think about it, some sort of entropy argument, why would everyone just move to this side? Unless there's some sort of higher levels you can get to where you might try and help pull people across to level 1. Okay, so if you're realizing that there's ethics in math, you realize that, you know, you have an employer who pays you money to do stuff, and that stuff that you do involves a lot of mathematics. Well, that's fine, but these people have an agenda. Right? You don't have a God-given right to be doing mathematics. Don't let anyone tell you otherwise. It has not been written in the stars that you shall spend your entire life studying mathematics at the expense of society. Someone's paying for your coffee, for your Coke, for your biscuits, for the heating, for your dinner, for your bed. So if you're doing that, then it's because somebody wants to pay you for it. And they have a reason to take on your services. So realizing that if someone's paying you to do something, they want it for a reason. Okay, this is all part of level 1. But your actions might have consequences. You know, you tell your employer, I don't want to do that, or I think it's a bad idea, or let's do it differently, and they get narky, they might listen to you. They might change it a bit, and you're happy enough with that. Or they might say, actually, no, you do it this way or you get fired. It's my way or the highway. So you might get fired, you might, even worse, get blacklisted from a particular industry. You know, he's a troublemaker, a radical thinker, someone who questions what's being put in front of them. You know, this is just math. Why do mathematicians question what's going in front of them? So if you try and raise these questions, you might meet with some difficulty, some resistance. Making you aware of that. It's not just all roses and playing in the fields here. It actually does become challenging, even in this level 1. So a common question I've had relating to level 1 is, oh, you know, if I'm presented with something I don't want to do, how do I properly sort of push back without blowing myself up? And if the choice does come down to, you know, do it or blow myself up, how do I decide that? Because, you know, you might have a family, or, you know, expenses, things like this, and all of a sudden someone threatening you to take away your job is actually a serious problem. It's a really serious problem. You don't want to end up in that situation. So it's a legitimate question. What do I do when I'm faced with, you know, on the one hand, losing my job, you know, jeopardizing my family, on the other hand, you know, betraying my morals? How do I make that decision? And my response to that is, if you're in a position where to keep your job you have to betray your values, then you're already screwed. The ship has sailed. You're now just deciding how you want to, you know, be finished off. You're sort of deciding, you know, what music you want played at your own funeral. I mean, yeah, it's a decision. It's a nice choice. We saw a good choice last week. So you have a choice, but it's a pretty shitty choice because basically you're screwed. The challenge is not to reach that point. That's a point of no return. The challenge is to have the foresight to realize long before it happens that, hang on, I'm heading down a path that might take me to this bad place. I can see what my employer is doing. I can see what sort of work I'm being asked to do here. I can see where it might go. Because I'm going to stop and think about it. When all my other colleagues are downstairs playing ping pong at 5 o'clock on Friday, I'm going to just sit and think for another 20 minutes. Then I'll join them and play ping pong. For those 20 minutes, I'll sit and think. What am I doing? What are we doing? Where is this going to head? So when I see that the train is heading towards, you know, a cliff with no bridge, I have time to get off. Okay, I don't like the way this is going. I'm going to sort of slowly move away from the project, go do something else, try looking for a new job. I've got sort of transition time. Or start rallying other co-workers around me to try and fight back against if you don't do what someone else will. So if I see things are going astray, I can start talking to my co-workers and saying, hey, I don't think we should be doing this, you know. I can do calculus, you can do calculus, you can do calculus. The three of us here in the room are going to do calculus. Let's decide not to do this. Or let's at least agree on some sort of basic principles we want to operate under. So when the boss comes along and says, I'll fire you, and Fred will do it, you can say, no, Fred won't. I already spoken to Fred. And Jane and Sue and Mark and whatever, I'm not going to do it. So to see this before it happens, that's what I mean by having an awareness of ethics and mathematics. Not just bumbling along going, oh, there's ethics in math, I'm fine, oh, I'm screwed. Proper foresight. It's a challenge. It's one thing to hear what I've been telling you for the last 7 weeks. It's another thing to act on it with foresight. And that's already tough.
Maurice?
Yes?
Is this the appropriate moment to interject and say no if it isn't? To remind the audience how much power they have, because mathematicians are rare, For example, the NSA not getting enough people in.
Yes, that's a sensible thing to raise at this point. The NSA and other surveillance agencies are struggling. Actually, give me 30 seconds and I'll raise that, because it ties in what I'm going to say now. So, perhaps you're an organisation and you want to go all out. You may even decide to be a whistleblower and say, no, this is screwball. I'm gonna blow the top off this. That's a very extreme thing to do. And we have examples of mathematicians or mathematically trained people who have done that. We have Bill Binney, Thomas Drake, Edward Snowden. All these people came and spoke for us in the last 18 months. Mathematically trained people who said, no, this is just wrong, with a capital R, and I'm going public. Now, their lives were not made very easy after that. I hear Ed's working on his Cyrillic at the moment as he spends the rest of his days in Moscow, because if he ever sets foot in an English-speaking country between now and 2097, he will be obliterated. So sometimes it can be a genuinely hard decision. Genuinely hard decision. But you can also have a large impact with a hard decision. After 2013, NSA, GCHQ, really struggling to recruit. Genuinely not getting the numbers that they want. And actually, this is something that I thought about on the way in this morning. After World War II, mathematicians had done something pretty amazing at Bletchley. Small bunch of mathematicians kind of single-handedly reduced the length of the war fairly substantially. Very low cost, very cheap. You know, how many tweed jackets did you need to buy them? Not that big. Tweed's fairly cheap. So a small number of mathematicians with a little sort of doohickey in the background, made from old British telecom parts, were able to shorten the war by 2 years. That's a hell of an investment. Even Warren Buffett would go, yeah, I'm going to put $20 in on that. That's a good return. Because wars cost you a lot of money per hour, let alone per year. So, yes. Yes? Yeah. True.
If we had one, it might have been because the Germans, for example, had a bunch of mathematicians.
Yeah. Mathematicians would have shortened the war on one side or the other. but in this case, this was a war where the UK was not the aggressor. So it shortened the war in favour of the side that were the defenders. But at that point, government sort of realised, oh, hang on, these mathematician people, they're kind of good value. And it's sort of sprung up that everything that we did was basically coded in gold. Mathematicians do lots of, they'll do amazing work, cost you next to nothing, and get this awesome stuff out of it. It's only now that we're just starting to get a little bit of negative attention and a little bit of self-realization at the same time. Which is why state surveillance agencies, post-2013, are having a bit of trouble recruiting. So we do have this immense power. Because of how efficient we are per dollar spent on us in terms of work output, because of how few of us there really aren't many mathematicians going out there. Properly trained, good mathematicians. I made this point before. So we have that sort of leverage. That if we, even very loosely, collectively decide to do something, that makes a real substantial difference in many organisations.